Hey guys, welcome to day 8. We're going to be looking at properties of logs. Um, Specifically, we're going to look at this third bullet point. As far as in our Pearson, we're going to look at the change of base formula. Okay, so the change of base formula is used so you can calculate any base in the calculator using base 10 or base e. Be sure to end parentheses on top. So in other words, you'll sometimes see equations that look like the following. And it says log base b of m is equal to log of m over log of b. Okay? For instance, we've seen functions that look like the following. We've seen log base 2, and it could be a 4. Okay? And this we know is some value. And remember, we are best able to solve this if we rewrite it with the reverse Hart method and exponential notation. So 2 to the power of x, that's this one, and then we would say is equal to 4, okay? That's what's going on here. So we know that this x, for it to be true, this x has to be 2, okay? That means if this is 2, then this is equal to 2, okay? So log base 2 of 4 is equal to 2, okay? And we know that because of what we just did with the reverse Hart method. Now, what the change of base formula is looking at is that way back in the day when we were your age, our calculators were not as fancy as the ones that you guys have today, okay? So when we had something like log base 2 of 4, the way our program or our calculators were programmed back in the day, this was equivalent to something called change of base. So this change of base, we're going to use green, okay? So log base 2 of 4, which you guys are used to today, we had to interpret as this before, which was log of 4 divided by the log of 2, okay? So what used to be in our calculators is it was programmed this specific way, okay? And if I go to my calculator now, and I said log of 4, log of 4 divided by log of 2, you see that we get 2. And notice that when I press enter, it automatically gave it a base of 10. Okay, there's that common base again. It isn't written, but it's understood if nothing is there. Okay, so we don't have to put it, it's understood. But nonetheless, all of this equals 2. It equals to the way we used to do it, and it equals to the way you are doing it today. Okay, so we have fancier calculators that will do that change of base for us, where we just have to put 2 here, and then we put 4 here, and we get the same answer. So this is old school to get the answer. This is new school, if you will, with y'all's awesome calculators that you guys have now to get the same answer. But we will ask questions where you're going to have to know how to rewrite equations, but you have to understand this change of base formula. Okay, so you need to make sure, even though you have the fancy calculators, doesn't mean you don't have to learn this, because we will ask questions in a certain way that you have to make the correlation and understand how these are interchangeable. Okay, how the new is equal to the old, okay, and the rewrite thereof. Okay, so the same thing is happening over here, okay? This natural log, like we learned in the last couple of videos, the natural log is the same as log base e. So this is log base e of m over the log base e of b. These two right here are exactly the same, only I chose to just write natural log instead of log base e right here, and for the other one as well. But they mean the same exact things, okay? So if I wanted to rewrite this back to the new way, then b is going to be log, well, you wouldn't say natural log of b per se is m. I mean, you could, but natural log is usually, it doesn't have a base here. Okay, when you write natural log, it doesn't have a base because log base e is already saying that it's natural log. Okay, so let me go to the calculator real quick. And if we put natural log, see, it doesn't kick down a base automatically. Okay, so let me see if I were to go here. It doesn't kick natural log here. It only has a log base of some number. Okay, so log base of e, whoops, let me choose the proper e. That means just e by itself. E to the power of 1 is just e. This right here is going to be the natural log of x. Okay, but notice we cannot say the natural log of another base. Okay, so going back here, that's why we have natural log of m over natural log of b is also, this is also equivalent to this original piece here. Okay, so these two are variations. This one and this one are variations of what you would see in your new calculators as of right now. So you need to know both of these, okay? And notice the example that we have. Log base 5 of 7 is log of 7 over log of 5, or natural log of 7 over natural log of 5. Either one is going to work. And the reason why they work is these are proportions. It's like 1/2 is 2/4, okay, is 3/6, and so on and so forth. They're all going to be equal, but this one's saying a log base of e, this one's saying a log base of 10. Remember, that understood 10 is there if nothing is written. Okay, and yes, if we were to put this in our calculator, we do get 1.2091, and we can show that right here. Let me say menu 1.4, that's just clear storage. Menu 1.5, again, that's a good habit to get into. And if I did log base 5 of 7, and I just press enter, I get the same thing back. But if I press control enter, I get that decimal equivalent that was 1.2091. Okay, so control enter is another thing that you're going to use a lot of. Okay, and that's still the same thing as if you did what it said it's equal to log of 7 over log of 5. Control enter. Okay, and then notice that the 10s spat out. And yes, it would be the same if you put natural log of 7 over the natural log of 5. I just press enter, it won't show it. I have to press control enter for the calculator. Okay, so now let's go back. That's the change of base formula, just making sure that you understand how to rewrite in its equivalent. So what is the value of the expression? Okay, so our equation that we have, or our logarithm, is log base 81 of 27. This equals something. So the argument is 27, the base is 81. Okay, so it equals something. We'll just put question mark. And what we learned in this video is that we can use the change of base formula, and we can write this as log of 27 divided by the log of 81. Or if we wanted to, we just use the natural log of the same pieces, natural log over the natural log of 81. Okay, again, these are equivalent because they are ratios, one with the base of 10 in mind, and one with the base of e in mind. But nonetheless, the ratio, like that 1/2, 2/4 interpretation that I was comparing it to, is still going to be equivalent. Okay, notice this calculator, way old calculator back in the day, right? And it doesn't even have a division sign the way we're used to with these newer calculators. Okay, so let me do this again. Menu 1.4, menu 1.5. The equivalent here would be log of 27 over the log of 81. Control enter, there's my answer. But now, also we could just write this in as log base 81 of 27. Control answer, we get the same thing. So that's how that works. And all three of them are equivalent. That, the way I wrote it in the new school way, if you will, this way, and finally with a natural log ratio, they're all going to be equivalent. Okay, so change of base, if we did it one more time, log base 8 of 32 is going to be the same thing. Okay, so it's going to be the log of 32 over the log of 8, which is the same as the natural log of 32 over the natural log of 8, which is the same as what you guys are doing today of just log base 8 of 32. All these are the same. Okay, just make sure that you understand how to rewrite them. Again, because of the way you're going to be asked questions, you need to know this property per se. And real quick, just for extra practice, what I'm going to do is I'm going to show that log base 8 of 32 is equal to, let's say, x. We don't know what it's equal to. And just for the sake of practice, I'm going to do the reverse Hart method to get 8 to the power of x is equal to 32 to the power of 1. Okay, so 32 is just 32 to the power of 1. And the reason why I chose to do this as extra practice is ultimately we need to have learned that these have bases that are basically the same as each other, or they could be rewritten as such so that we can solve for x by hand. We need to also know how to do this by hand for like SAT non-calculator portions. So 8 is the same. Let me make some room. I'm going to do this up top. 8 is the same as 2 to the third. This x is still out there. Okay, so let me highlight so that you understand what I'm doing. And then 32 is the same as 2 to the raised to the power of 5. Okay, and this 1, this understood 1 is still out there. So let me highlight what's going on. This 32 to the power of 1 is 2 to the 5. 2 to the 5th power to the power of 1. And my goal there was, the reason why I did that is because now I have the same basis. Again, I'm trying to show you this is a skill that you need to know to do it by hand, not just with the calculator. So power raised to a power, we multiply. Power raised to a power, we multiply. So I have 2 raised to the power of 3x is equal to 2 raised to the power of 5. That means if those bases are the same, which that's what that was my strategy here, then they're negligible. I don't even have to think about them anymore because these will be the same. The left will equal the right. This left side will equal the right side if the powers are the same, because the bases are already the same. I made them the same. So 3x is equal to 5. X would be 5/3. So x is 5/3. That means, let me show you right here. X is 5/3, means this is 5/3, which means this whole thing must equal 5/3. Okay, so let's go to the calculator. So we have log base 8 of 32. Sure enough, gives you 5/3. Okay, and what we learned with this change of base is the same as saying the log of 32 over the log of 8. Oops. You get 5/3, or the natural log. The natural log of 32 over the natural log of 8. That's it, guys. That's it for this video.